So welcome everybody to this latest video on 160 Maths, and in this video we'll be continuing with our series of revision material for the AQA GCSE Maths paper of 2022, and in this video we'll be going over the higher paper 2 Algebra section. Now there will be a copy of the questions that we go through in this video for you to download and have an attempt at before or during watching this video. So before we get started, let's have a quick breakdown of the topics on the Algebra section for this paper 2 higher paper. Now looking at the topics, I would say a lot of these topics kind of can be merged into one. Now the key thing to remember is with this advanced notice is that you're not going to have an individual question based on every single topic that's on this list, not just in the algebra section, not in the number section, not in the geometry and measure sections. A lot of these topics are going to be merged. You're not going to end up with an exam paper with about 50 questions. So looking at the advanced notice, you want to try and see which types of questions you could possibly merge together. Now that in itself is quite a difficult task for anyone to do, whether you're experienced or a teacher or a student. So it's important that you do understand each of these elements, but appreciate that it is not going to be explicit that you're going to see exactly what each of these topics in your exam paper. So looking at this algebra section, you want to see which ones merge together. So I would say that the factorizing of a quadratic can be linked with completing a square, which can be linked with a coordinate problem, which can be linked with turning points. So I could easily create a question that merges those four topics, and it's not explicit that you're going to be using each of these four things. It could be going to then. It's also linked with quadratics as well. So it could be potentially where you're plotting a graph and you have to state certain points or the roots or the minimum point or the y-intercept, etc. So let's break down this particular list. So looking at the first one, it says equations. So this is where you're actually solving the equations or writing an equation. Now the first one is of a circle. Now at this level, unless you're doing further maths, the general formula is x squared plus y squared equals r squared, where x and y are obviously your coordinates and r is your radius. Now the key thing to remember is that in the equation it's r squared, so if the radius was 6, then x squared plus y squared would equal 36. So it's always important, and obviously you can end up with a surds with this being a higher paper. When it comes to linear equations, again, this could appear as a very, very simple question, or it could be a complicated question. So it could be a single-sided, could be multiple choice, could be dealing with negative x's, double-sided, equations with fractions and brackets. So basically when you're dealing with a single x, which is what this topic is then leading on to. Moving on to quadratics, again, this could be a combination of things. So with it being equations and quadratic equations, I'm probably going to go through on a limb and say it's going to involve solving a quadratic. So again, this could be a very simple quadratic equation of x squared, just a single x squared. It could be a more complicated one. It could be using the formula, could be using completing the square, which we've already mentioned, or it could involve a graph, which again, there are other sort of links to potential graph, quadratic graph questions coming up. Then it moves on to number line inequality. So again, I've not really put our last on this one because it's quite self-explanatory. So this again could be a multiple choice question, could be one of the very early questions, but basically representing an inequality using a number line. And just remember that if you have got an inequality that looks like a bound, that you want to make sure that the x or the n or whatever letters in the middle is a single. So here I would need to divide by 2, so that becomes 1.5 and that becomes 3. And then I would represent that on a number line. Remember, if it hasn't got an equal to, it's a unshaded circle, and if it has got an equals to, you've then got to colour that in. The next one is factorization of a quadratic. So again, looking at this could be involve double brackets. It's not going to involve the quadratic formula, but it could include ax squared plus bx plus c, particularly if it's in the latter parts of the exam paper. Also difference of two squares and completing the square. So it's really important that you're able to establish when to use each of those four methods. The next one is multiplying out. So again, we're probably looking at expanding brackets. So again, either in the form of a quadratic or a linear equation. So just making sure you're working with brackets. Completing the square, again, could involve factorizing or solving. Coordinate problems, that one's a little bit more difficult. I don't know why that arrow is pointing so there, so let me just change that to here. So this is where, again, typical coordinate problems I've seen in past papers are where you have got, let's say, certain corners of a shape and you need to write down the coordinates of a third to make it a parallelogram or an isosceles or equilateral triangle. Potential midpoints of coordinates, so again, it could be linked with ratios and also points on a line, again, just to see whether, and what I mean by that is if they give you an equation, they're probably asking you if a coordinate lies on the line. So that's where you substitute your x coordinate and see if it gives you the respective y ordinate. The next one is perpendicular line. So again, writing equations, so where they give you one equation of a line and they want you to write a line that's perpendicular going through a particular point. So again, using y equals mx plus c, or using y minus y1 equals x minus x1 formula to write that down. Could be a case of just proving whether two lines are perpendicular or not. So again, all you want to look out for here is the gradient value, so the m value. And if it's perpendicular, it's going to be a negative reciprocal of that coordinate, of that line, sorry. Turning points, again, heavily linked with completing the square, and I would say with this being on the revision list, I would say it's definitely going to be linked to the completing the square diagram. So in terms of that, you want to be able to recognize when the turning point is when you have factorized it in completing the square format. The next one is inverse functions. So again, self-explanatory in terms of that. There's many practice questions you could do on this. And several steps in which, if you're not sure about that, then I'll add a link to a video where it covers this. And then sequences in terms of triangular numbers. It's difficult on this one. I would say just recognizing your triangle numbers, learn your triangle numbers and know how to derive them. Again, I would go on a limb and say that this one is more likely to be a multiple choice question at the very start. So let's have a look at some example questions. Now, if you wanted to have a go at these questions before watching this video and the walkthrough through the questions, then you can download the question sheet by clicking on the link in the description below. So looking at question 1, which is related to the equation of a circle, it says that a circle has its center at the origin and has the equation of x squared plus y squared equals 81. What is the size of the radius? So for this, recognizing that this is r squared. So if r squared is 81, then r is going to equal the square root of 81, so r equals 9. Now we don't need to put any units on that because we don't know what the units of the circle of the drawn circle is going to be. So don't write centimeters, don't write length units or anything like that. It's going to be absolutely fine. Also, do not write plus or minus 9 because here, as we're talking about the radius being a length, it can't equal a negative length. So do not write minus 9. The answer then would be positive 9. Moving on to question 2, so again related to equation of a circle, it says the circle has the equation of x squared plus y squared equals 25. The circle passes through the points A, B, C and D. Complete the coordinates of A, B and C and D. So for this, all we need to do here is substitute these ordinates into the equation and find the respective variable. So here what we're going to do is we're going to sub in x equals 5. So here I've got 25 plus y squared equals 25. So y squared equals 0. So y is going to equal 0. For this next one, I'm making y equal to minus 5. So here I've got x squared plus then minus 5 squared is 25. So that equals 25. And then x squared equals 0. So x equals 0. Then for C, again, I'm substituting y equals 0. So here I've got x squared plus 0 squared, which is 0, equals 25. So x equals plus or minus 5. Now, we've already got plus 5, so C must equal minus 5. Otherwise, C is going to be on top of A. Then for D, here we're making x equals 0. So here I've got 0 squared plus y squared equals 25. So y squared equals 25. So y equals plus or minus 5. Now we've already used y equals minus 5, so it must equal plus 5. So there is my final answer. Moving on to question 3, it says describe fully the graph which has the equation of x squared plus y squared equals 9. So for this, we just need to state that it's a circle with a center of being the origin or 0, 0 and a radius of 3. So I would say that if this was worth 3 marks, you get 1 mark for mentioning it's a circle, 1 mark for mentioning the center, and 1 mark for stating the radius. Then with question 4, it says write the equations of the circles with the center origin. So for this, Again, now the general formula for the equation of a circle looks something like this. Now, again, this might be beyond what your teachers have taught you because it tends to be more further maths sort of formula, but the center is the coordinates of AB and the radius is equal to R. So all we've got to do is substitute this. So the center of the origin is the origin, then A and B are going to be 0. So for this, it's going to be x squared plus y squared equals 3 over 2 squared. Now, if I simplified that, which I'd probably expect people to do, then we'd get 9 over 4. Then with B, we've got x squared plus y squared equals 0.5 squared, which then gives me x squared plus y squared equals 0.25. And for C, we've got x squared plus y squared equals root 3 squared. And so obviously that then cancels with that. So all I'm left with is x squared plus y squared equals 3. Moving on to question 5, it says the equation of the circle C is x squared plus y squared equals 25. Circle C is translated by the vector of 3, 0 to give the center, to give circle D. Complete the coordinates, the center of, well, what we need to do is write down the new center of circle D. So looking at this circle, I just do a very, very poor diagram. Then we know that this radius has got a radius of 5. Now this center has been shifted 3 to the right. So what then it looks like is it looks something like this, where this is now at 3. Now this coordinate here is at 3, 0. Now in terms of the intersection points of the x-axis, well here at this point, because the radius is 5, that's going to be at -5 and this is going to be at 5. Now it's been shifted 3 squares to the right, then this here is going to be -3 plus 3, which is -2. And this point here is going to be 5 plus 3, which is 8. So here, all I'm then doing is substituting the coordinates. So this point here is going to be -2, 0. And then this point here is going to be 8, 0. Then moving on to question 6. So this looks at factorizing quadratics. So we're just looking at simple double bracket questions. So looking at this one, I need to find two numbers that multiply together to give me 16, add together give me 10. So here I'm looking at 8 and 2 and writing my x's. Now because this is a plus, that means that the biggest number is going to be a plus, and because this is a plus, it means that the signs are going to be the same. So it's x plus 8 and x plus 2 in any order. For the next one, it's going to be x and x. And then so here, two numbers that multiply to give me 12, added together to give me 7. Here I'm looking at 3 and 4, and again, they're both going to be plus. And then finally, for C, two numbers that multiply together to give me 12, added together to give me 13, where it's going to be 12 and 1. And there again, they are both pluses. Moving on to question 7, it says factorize again. So this time we've got a mixture of negatives. So just got to be careful with the signs. So for the A, two numbers that multiply together give me -6. So here I'm looking at 6 and 1. And one's a minus and one's a plus. Now here you might be thinking of 3 and 2, but the problem is that because the sign of the constant is a negative, it means that the signs are going to be different. And obviously to get -5, it's going to be -2, -3, which could be +6. So that there would be our correct answer. Yeah. Question B, again, two numbers that multiply together to give me 40 with a difference of 3. So here we're looking at 8 and 5. And so because this is a plus, the bigger number is going to be a plus. And because this is a minus, means the signs are going to be different. So here we've got x plus 8, x minus 5. And then for C, we've got, let's just set up our brackets. So two numbers are multiplied together give me 30, added together give me 7. So here I'm looking at either. So for 30, I'm looking at 6 and 5, which again I can't make. 15 and 2, which again is not going to be right. 3 and 10, That looks more reasonable. So I'm looking at 3 and 10. This is a sign of the bigger number, so that's going to be a minus, and that's because that's a negative, the signs are going to be different, so it's going to be a plus. And again, you could write those brackets in any order for them to be correct. Moving on to question 8, so this is where we've got to factorize a more complicated quadratic equation where we've got a constant of x squared which is greater than 1. Now again, you are only going to get marks for the brackets and as long as they are correct. So in terms of the methods, you could do this by inspection by just simply guessing or by looking at the equation and going straight to the answer. But I'm going to use the actual magic number way of working this out. So here I'm going to do 3 times 2. So my magic number is going to be 6. So I'm looking for 2 numbers that multiply together to give me 6 and added together to give me my b value, which in this case is positive 5. So here I'm looking at 2 and 3. So from this, all I'm going to do is I'm going to swap the 5x with 2 and 3. So I've got 3x squared plus 3x plus 2x plus 2. Then factorising the pairs, I've got 3x, and I've got x plus 1 plus 2, and then x plus 1. And those two brackets should be the same, which they are. So then one bracket is 3x plus 2, and the second bracket is x plus 1. Moving on to question 9. So again, very, very similar. So here my magic number is going to be 6 times 4, which is, let's call it mn, which is 24. So I'm looking for 2 numbers that multiply together to give me 24, but added together to give me 11. So here I'm looking at 8 and 3. So then swapping the numbers in, I'm going to get 6x squared plus 3x plus 8x plus 4. And factorising the pairs, I get 3x again. So here I've got 2x plus 1. And then factorising this, I get 4. And then 2x plus 1. So then one bracket is 3x plus 4. And the second bracket is 2x plus 1. Moving on to question 10. So here we've got to express this in completing the square. So here I've set up my bracket. So I've got x squared and then plus 5. So then all I then need to do is divide that number by 2, the constant of x. I don't know why I've wrote a plus there, so let's get rid of that. So here I've got minus 4, and then I always take away whatever digit is inside the bracket squared. So then simplifying this, I get x minus 4 squared plus 5 minus 16, giving me a final answer of x minus 4 squared minus 11. Then moving on to question 11, it says that show that x squared minus 8x plus 20 can be written in the form of this, where a is an integer. So again, all I'm going to do is just ignore the format. It's just telling me to write it and completing the square. So I've got x minus 4 squared plus 20 minus 4 squared. So I've got x minus 4 squared plus 20 minus 16. I've got x minus 4 squared plus 4. Then says, hence explain how you know that x squared minus 8x plus 20 is always positive. Well, it's always positive as we have a plus 4 as a constant. Oh, as we have, I should say. Plus 4. So here we've got x minus 4 squared plus 4. Now basically what you're trying to translate is that the smallest number that this could ever be is going to be 0. So if that's the smallest it could ever be, is going to be 0. So we're then adding 4. So that means that the equation of the line is always going to be greater or equal to positive 4. So if this number here, when you factorize it in completing the square format, is either positive, then the answer will always, well, for all values of x, is always going to give you a positive answer. Moving on to question 12, it says find the values of a and b such that. So again, we want to use completing the square. So here I've got x plus 1 squared minus 7 minus 1 squared. So I've got x plus 1 squared minus 7 minus 1, which leaves me with my final answer of x plus 1 squared minus 8. Then moving on to question 13, which looks at perpendicular lines. So it says, now remember that if a line, the key thing to remember is if a line is perpendicular to y equals mx plus c, or in other words m, then its gradient will be the negative reciprocal. So that's the key thing you need to remember when it comes to perpendicular lines. So looking at question A, it says if a gradient of the line of A is 4, what's the gradient of a line that's perpendicular? Well, it's going to be minus 1 over 4 because the gradient is 4. Moving on to B, here we've got a gradient of minus 3, so it's going to be minus 1 over minus 3, which gives me a positive 1/3. And then for C, my gradient is 2/3, so I've got minus 1 over 2/3. Now when you're doing the reciprocal of a fraction, you just simply flip the fraction, so it becomes 3 over 2, and then not forgetting the minus, we change the sign as well. Now moving on to question 14, it says select the equation of the straight line that's perpendicular to the line y equals 3x minus 2. So here the gradient is 3, so I'm looking for a perp line gradient of minus 1 over 3. So which one of these sort of equations has a gradient of minus 1 over 3? Well, this one has a gradient of 3. This has a gradient of, well, we've divided by 3 of 1/3. This has a C has a gradient of minus 3. D has a gradient of minus 1/3, and E has a gradient of 1/3. So the correct answer then is going to be D. Then moving on to question 15, it says find the equation of the straight line passing through the point 0, 1, which is perpendicular to the line y equals minus 2x plus 1. So for this, what we've got is the gradient of this is going to be minus 2. So then the new gradient, the gradient of the perpendicular line, is going to equal minus 1 over minus 2. So it's going to equal 1/2. So from this, now there's a couple of ways in which you can do this. If you're using y equals mx plus c, then we know that m equals 1/2. We know that x equals 0 and y equals 1. So from this, what we can then do is substitute the numbers in. So I've got 1 equals 0 times 1/2 plus c. So then c equals 1. So then the equation of the line is going to be y equals 1/2 x plus 1. Then if you're using y minus y1 equals mx minus x1, then again m equals 1/2, x equals 0, and y equals 1. So what I've got is I've got y minus 1 equals 1/2 x minus 0. So then I've got y minus 1 equals 1/2 x, and then y equals 1/2 x plus 1. So you get exactly the same answer, and it's entirely up to you which one you use. For question 16, it says the graph shows the graph of y equals x squared plus 4x plus 3 is shown. What are the coordinates of the turning point? Now the turning point is this point here. So what coordinate is that? Well, that's going to be minus 2, minus 1. The next question then says what are the coordinates of the roots of the equation? Well, the roots are where the line crosses the x-axis. So it's at this point here and this point here. So the coordinates are going to be minus 3, 0, and minus 1, 0. Question 17, it says that the graph of y equals f of x is shown. Find f of 0. So this is basically where we're substituting where x equals 0. So x equals 0 is going to be basically where the x is crosses where the line crosses the y axis. So it's looking for the y-intercept. So here the y-intercept is at 0, 2. So here then the answer is just 2. Next question then says give the roots of f of x equals 0. So this is where it crosses the y-axis. So this would be the two roots. So here we're looking for minus 2 and minus 1. For question 18, it says this is a sketch of the graph of y equals x minus 1 multiplied by x minus 3. Write down the coordinates of points A and B. Now, A and B are the roots, so we just need to solve this quadratic equation where y equals 0. So here we're looking for x equals 1 and x equals 3. Now, A is the smaller of the two, so that's going to be 1, 0, and B is going to be 3, 0. The next point is point B. Now, this is the y-intercept. Now, to find the y-intercept, x equals 0. So if I substitute x equals 0 into the equation, I end up with y equals 0 minus 1 multiplied by 0 minus 3, which is minus 1 times minus 3, which is positive 3. So it's going to be 0, 3. And then finally, write down the coordinates of the turning point. Well, for this, I need to expand the equation. So I've got y equals x squared minus 4x plus 3. And then I've got to use completing the square. So I've got y equals x minus 2 squared plus 3 minus 4. So I've got x minus 2 squared minus 1. So then the turning point is the reverse of this number, which is positive 2. And it's taking this value here, which is minus 1. Then moving on to question 19, which is looking at functions. So it says if f of x equals 3x minus 2, find the inverse function of x. So again, the steps are you make the function equal to y, and then you want to make x the subject. So I've got y plus 2 equals 3x, and then y plus 2 all divided by 3 equals x. So then f of x, the inverse function of x, equals x plus 2 over 3. And then for b, all I then need to do is substitute x equals 13 into the inverse function. So I've got 13 plus 2 divided by 3, which is 15 divided by 3, which is 5. Moving on to question 20, it says given that the function of x is x squared minus 3, find f of 3. So this, all I need to do is sub x equals 3 into x squared minus 3 over 2. So doing just that, end up with 9 minus 3 divided by 2, which is 6 over 2, which is 3. Next question then says find the inverse function. So if I make it equal to y, and then all I then need to do is make x the subject. So I've got 2y equals x squared minus 3. So 2y plus 3 equals x squared. So x equals the square root plus or minus of 2y plus 3. So the inverse function of x equals plus or minus the square root of 2x plus 3. I don't know why I've put a bracket there, so let's get rid of that. And let's just put a roof on that square root. The next question then says substitute 11 into this. So all I'm doing is substitute x equals 11 into that. So I've got plus or minus 2 times 11 plus 3, which gives me plus or minus 22 plus 3, which is 25. So then I'm getting an answer of x equal, the function equals plus or minus 5. Then moving on to question 21, it says the inverse function f of x of the inverse function of f minus 1x of f of x is x plus 5 over x, can be written as 5 over x minus 1. Find f of 2. So for this, what we need to do first is to work out, well, this, let's just write down the formula. So f of x equals x plus 5 over x, and the inverse function of x equals 5 over x minus 1. So for this, all I need to do is substitute x equals 2 into this first one. So with a, I've got 2 plus 5 over 2, so that's going to be 3.5. And then with b, I'm just substituting 2 into the inverse function, so I've got 5 over 2 minus 1, which gives me an answer of 5. So moving on to question 22. So we've got another inverse function question, but this one's going to be a little bit more complicated and a lot higher level, simply because we've got a double x and a fraction. But again, the sort of method is going to be exactly the same. So we make it equal to y. And then what we then want to do is make x a subject. Now, if I just put brackets around the denominator, I take that over to the side. So I end up with y, x minus 5 and 2x. I then expand the brackets, so I get xy minus 5y equals 2x. I then take everything with an x all onto one side, so I end up with xy minus 2x equals 5y. So all I've done there is I've taken this 5y over to this side and the 2x over to the left hand side. Then what you want to do here is then factorize with respect to x. So here I've got y minus 2 equals 5y, and then we're going to take this bracket over to the side, so I end up with x equals 5y all divided by y minus 2. And then from this, all we then need to do is do a few replacements. So here I've got 5x over x minus 2 as my final answer. Moving on to question 23. So here we move on to our coordinates problems. So it says the points A, B and C are three corners of a rectangle. What are the coordinates of D in the fourth corner? So here our fourth corner is going to be here. We'll just label that as D. And then the question is asking for the coordinates, not plotting it. So it's going to be 5, 7. And moving on to question 24, it says the points A, B and C are 3 points. What type of triangle is this? So again, so what we need to do is just accurately plot these. So I've got minus 3, minus 2, which is there. Minus 3, 3 is there. And 5, 3, which is here. And as you can see, what type of triangle is that going to make? Well, if I join the points up, it makes a right angle triangle. Other possible triangles it could be is isosceles, equilateral, scalene, along those lines. Moving on to question 25. So here we're just expanding the brackets. So again, always remember the loops. So here I've got 6x squared plus 9x plus 8x plus 12. And then it's just a case of joining the coefficients of x up. So I've got 6x squared plus 17x plus 12. Moving on to question 26, again expanding the brackets. And again, it's always worth just making sure that you are using those loops. Only takes a couple of seconds, and just be mindful when you have got a negative outside the second bracket. So that's going to be minus 3x, and then minus 3 times minus 2, which is positive 6. And then it's just a case of collecting the like terms. So I've got 6x minus 3x, which is 3x, and then 8 plus 6, which is 14. Moving on to question 27. So here we're looking at number lines and inequality. So what is inequality shown? Well, here I've got minus 4. I'm going to use an n because I've got n there, and I've got a 5. Now, if the circle is unshaded, then it's just going to be a simple line there. And obviously the next one is shaded, so there would be our corrected answer. Question 28. Again, very similar. So start off by writing the two numbers with n in the middle. And then this one is unshaded, so it's going to be less than. This one is shaded, so it's going to be less or equal to. Moving on to question 29. So this is looking at difference of two squares. So we're just factorizing the quadratics. So again, this is a dots question. So I've set up my double brackets. What do I need to square to get x squared? X. What do I need to square to get 9? That's going to be a 3. One's a plus, one's a minus. And it doesn't matter which order you put those brackets. Question 30, again, setting up my double brackets. I've got, what do I need to square to get x squared? X. What do I need to square to get 100? 10. One's a plus, one's a minus. Moving on to question 31. So again, set up my double brackets. What do I need to square to get 9? X squared, well, that's going to be 3x. What do we need to square to get 64? That's going to be 8. One's a plus, one's a minus. Job done. Then with 32, again, very, very similar to the previous question. So I set up my double brackets. This is going to be 7x. And this is going to be 11. one's a plus, one's a minus. And then moving on to our last and final question. So here we've got double letters. So here again, exactly the same format. To get 4x squared, I need 2x squared. And to get y squared, that's just going to be a y. One's a plus and one's a minus. And we are done.